Okay, let's look at multiplying numbers in polar form and multiplying complex numbers in polar form. So what we're going to look at here is we're going to try and we're going to prove this formula, that cis of theta times cis of phi is equal to cis of theta plus phi. Okay, so looking at this, you know that cis is cosine theta plus I sine theta. And then this one becomes, multiplied. This becomes cis of phi plus I sine of phi. All of a sudden, I forgot which side I wanted to start on. I think it should work either way. Okay, so let's keep going. So then this becomes cosine times cosine of theta times cosine of phi plus I sine phi cosine of theta plus this should be cosine. I'm so sorry. Yes, okay. It's too early in the morning. I apologize. Sine theta cosine phi, and then I have plus I squared sine theta sine phi. Okay, so this stays real right here because of the -1. So I'm going to take this part and this part. Those are the real parts of this expansion, and that becomes cosine theta cosine phi minus sine theta sine phi. And then the imaginary part are these other two, and I'm going to say, okay, so this is plus I times, sine phi cosine theta plus cosine phi sine theta. I switched the order of this one right here, so it's sine, cosine, cosine, sine. And now, hopefully, what you recognize here is that this is the cosine. If you remember back to your angle sum identities, this is cosine, cosine, sine, sine with a minus in here becomes cosine of this plus this. So this part right here becomes cosine of theta plus phi. And then we have this other part here, plus I'm sorry if it's hanging off the screen. It's I times, sine, cosine, cosine, sine with a plus sign in the middle. This becomes sine of, theta plus phi. We can add those two angles together. And so now you may notice this is cosine of something plus I sine of something. We can call that cis of that something, which is this. So we have just proved that that cis of theta times cis of phi is equal to cis of theta plus phi. So in other words, if I say, okay, I've got cis of pi over 6 times cis of pi over 4. Okay, what I can do is I can say, this is just going to be equal to cis of, when I add those together, that's 2 over 12 and 3 over 12. That's 5 pi over 12. Something like this. This one's not great because you can't really keep going without, this isn't on the unit circle. But anyway, it's that sort of idea if you're multiplying these two complex numbers. And this will be helpful in the future. What do you think we might be able to say about if I expand this out, or if I extend this to cis of theta divided by cis of phi? If I'm dividing, this ends up working out in a similar way where you can say that it's cis of theta minus phi. Okay, so instead of multiplying and getting where you add them, you can divide and get where you subtract them. I don't know that I'm going to do a proof of that, but there you go. And then the other one that they point out in the book is that cis of theta plus 2 pi k. Well, if you think about this, if you're on the unit circle, wherever your angle theta is, I don't care. If you add 2 pi k, it's always going to be coterminal. Okay, so if this is whatever your theta is, and then you've added 10 pi k, you end up right at the same spot, and it's got the same cosine and the I sine. So this is just equal to cis of theta, and that will become important later. Okay, that's video number 1 for this morning. So I'm going to keep going, but find me in the next one.